Well, so this is what I'm doing in all the other classes, so I'll do it here. Um, Unfortunately, every room in this place is different. So other rooms have big cameras, other rooms have, so I don't know, there's no consistency, so I can try to make the best consistency out of this thing as I can. So have y'all, here, let me log in. What I've been doing in the other classes is just going and working the homework problems. We missed Monday, so do y'all want an extra couple streaming lectures out of that, or have y'all looked at the material and realized?
I think the material you folks have been doing good enough right now.
Oh, is it?
I felt pretty comfortable with fluid so far.
Okay. Oh, is it gonna make me do that thing? Oh, good. Okay. So let's just do this. Let's go in and see. There's a couple problems that I've noticed. Seems like every single time in fluids. And let me see if I can address that one by finding a problem that's in the homework that's like that. First of all, let's open. Now, I'm not sure where it would be, so I'm going to pick week 4. No, it would probably be week 5. Okay, let me go to week 5. Week 5. I just opened week 5, didn't I? Okay, see, I have to apologize. I put tons of stuff out there. I mean, there's more lecture time out there than there is that would be in a normal class. But there's one problem. I'm going to go ahead and open week 6 because it may be in week 6. Okay, yeah, I think this is where it's related to this, which is these gates. So there's a couple of things I want to kind of bring up, and maybe let me find a problem in here. And let's see. Yeah, that would, either one of those, maybe. I don't know. That second one looked like it'd be a good one. And this one is a good one too. So let me do the second one. Is that the second one? The first one is maybe too boring. So let's do the second one. And I'm going to show you some weird things on it. So how do I get rid of this stuff here? Do I just drag it? Okay, I want to get rid of that. Where is the drag thing? Oh, there it is. Okay. The next thing, so this is what I do in the other class. So this is the most bizarre stuff I've ever had to do. But I'm streaming live at the same time that we're in class. Let's see if I can find it. That's statics. I already did that, so. Okay, it's down there somewhere. Maybe it'll show up. Okay, give me a minute. 'Cause I just want to make sure that, wait, that's statics. Okay, tell you what. Let's go here. Oh,
How come
geez.
you're going to week 6?
Huh?
How come you're going to week 6?
Oh, because these are the ones that will present some problems for you. That's the reason. So this is just chapter 2, actually. So actually, technically, this probably should be back around week 3. So I followed the thing I was doing last semester. So I went a little slower than I should have. Let me see if I can find this to make sure I'm actually, okay, there's fluids. Okay, yeah, it's on. Problem is, camera doesn't point, and this thing even, I'm probably gonna break something if I don't know. there have been several people in all of my classes that have tested or had to go into quarantine. I don't know, let's give it a second and see if that, because that's live right now, so. Oh, it's dead.
No, I think you're just moving around.
Oh, okay.
There's a little delay on
Oh, okay. Looks like I'm standing in front of it. And it is, why? Am I not seeing something there? What the heck is
Is there
going on?
like a cover on it?
Oh, it's got a cover thing. Oh. Okay, so it'll take me a few seconds for this to catch up. Let's make sure it. Good grief. Did I pause it? No? Oh, there we go. All right, that's good enough here. Yeah. Besides this thing, that is not full aspect ratio. So I don't know, there's going to be a part of, like I said, every room is different. So let's do a portion of this. It says the gate has a cross section of that picture. Closes and opening. This is kind of weird. Closes and opening 5 foot by 4 foot. So that kind of, does this move out of the way? That kind of to me implies that it's 5 foot into the board. Okay, and then it says, I guess I need to move the screen a little bit that way. And it says, high in the water reservoir. The gate weighs 500 pounds. The center of gravity is 1 foot to the left and 2 foot above BC. Determine the horizontal reaction that is developed on the gate at sea. So he says that's a hinge. So here, I guess I have to stand out of the way. So something's having to push on it there. So if you broke this gate down, this is kind of bad because everything I write, that camera's going to be in the way of it. Okay. So if you think about it, the one thing you picked up early in chapter 2 is that the pressure is equal to gamma H. Meaning, and you'll see it in the video, I'll make a goofy video where somebody takes a garden hose and swims down to the ground, and it will collapse their lungs, because as you get down, just like at the bottom of an aquarium or a swimming pool or something like that, you'll find out that as you go down, P atmosphere is up at the top, and down here, the pressure is equal to P atmosphere plus the gamma times the Z. I guess I should have wrote that over there, but here. So I'll say it like this. There are no more? Okay, there's the pressure. I'm really confused in this room. The pressure, say underwater, it doesn't have to be water, it could be oil or something, is equal to P atmosphere or pressure at the top plus the gamma times the height of the water, or the depth of the water you swim down. So in fact, if you look at it, what this is saying is this is P atmosphere. Now when you were in thermo, because you had to have that class, things they were really very particular about P absolute and temperature absolute. And there's a reason being, and that is you did this, well, you did this. And so this had to be absolute, and this had to be absolute too, because you were working through this equation. But now you're not working through that equation. It can be gauge. So in fact, if this is P atmosphere back here, then you can just work this problem without those two. Then you could go down and say, okay, I'm going to go down to this depth. The pressure here is equal to 8 foot if it's water, 62.4. Because that's, if you take a 1 foot by 1 foot by 1 foot aquarium, and you do that, you'll find out that in fact it's 62.4 pounds. Now, if you heat it up or cool it down or something, you may get some water spilling over the side, and you might get a slight difference. So that's not absolute. You can bring it down to 62.1 or up past that a little bit, depending on the temperature. But that's the one that they call as the standard, like 4 degrees centigrade. You know why? It's okay to use that, and that's what it uses throughout the book. So the pressure at that point is that. The pressure at this point is equal to 8, 9, 10, 11, 12 times 62.4. Now, if you want to redraw this triangle, I'll just draw the BA face. This is the B. That's the A. So if I were to draw this pressure on that surface, it would look just like this. Okay, now I'm going to make this is not to scale, by the way. It would look just like this. The thing is, the pressure is going to be larger the deeper you swim down. So it becomes a statics problem. This pressure becomes, I don't know what that is, but I'm just going to keep going like this and then put numbers in it in a second. In other words, I may not multiply them out ever. The pressure over here is 12, and I don't know why I was about right, 8, but 12 times 62.4. Now, if you look at this, it's in pounds per square foot, because this is in, okay, I should put the correct units here. It's pounds per square cubic foot of the aquarium. So if you have a cubic foot of aquarium, you can go try that if you want to. It seems like a weird thing to do, but if you do have an aquarium, you start moving stuff around, you find out water is not exactly, it's pretty heavy. It's not very light. So, in fact, what you end up with is pounds per square foot. It turns out this thing is 5 foot deep. So if you want to get rid of that, you can multiply this times 5, and you'd get pounds for no longer square foot, but for just foot. Now at this point, you can turn your head sideways, and I don't have much board space. So if you turn your head sideways, it looks like a funny statics problem, which is why this part is called fluid statics. You can split it and do the triangle part and this part. That's what I generally tend to do. It's the easiest thing to do. So, if you want the equivalent load there, that's what you would get. Now, if you want to consider part across the bottom, the BC, I'll move the B over a little bit. I'll put the B in there. It's supposed to be a straight line. There's a force pushing up on this thing. So if you think about it, if you take a balloon, push it into water, the water's pushing up on it. It's also pushing down on it too. So in fact, find out is this pressure is whatever that number is. I don't know what that number is. Turns out it should be the same exact magnitude and constant across the bottom. And these are unified loads. Here, hang on a second. Yeah, let me do that first. So that number could be referred to here, but it also could be referred to there. Now, there's some issues with several things along here. First, the direction of the load. If I take my hand and I say I put, 10 psi more on this side than I have on this side, then it's gonna, if I turn my hand, the vector's gonna change. So it's perpendicular to it. So if it's a true pressure on one side, then as I turn it, I'm still being pushed down. So in fact, the direction is always perpendicular to the surface. So that causes, for some strange reason, that causes some difficulty. I'm not, I guess there are three different ways to work these type of problems. One way can take you into the abyss in the sense that you work extra hard. The other one is a generalization, which I can do one of those. And maybe I'll do a streaming lecture with a complete, I'll make up a problem and do a complete, all three different ways. I'll do the way I would do normally, which would be this. Then I'll do the generalization, and then I'll do the abyss kind of way. The abyss kind of way is like, okay, you could do it if you wanted to, but you're gonna work extra hard for no reason. So then that's all you're doing. What you do now is you could just, okay, so if I took this one and did like I did with that one, and I said, okay, I'm taking the vectors off. I'm just gonna make these volumes. Take all those off. And I'm just replacing it with the equivalent loads. And I have one going straight up. He says it weighs 500 pounds. Its center of gravity is 1 foot to the left of AC. If it's 1 foot to the left, it's probably maybe right here and 2 foot above BC. 2 foot above BC. Wait, how far? Oh, okay. So it's 4 foot total, so maybe about right there. So what did it say? 500 pounds? So this is 500. Now if you want to know this load, well, let's do this load first. If you do this load, that's nothing, that load is nothing more than 8 and 62.4 times 5, and you're back in statics now. You're looking at the area of this. This thing is that tall, but it's that long. Oh, it's a 3, 4, and so that's got to be a 5. And so that 5 comes from the fact that it's 5 right there. If that makes sense. Just 3, 4, 5. So you're looking at the area of this chunk. Likewise, you're looking at the area of that chunk. Did I put the 5? I did put the 5. Okay. So this is pounds per square foot, pounds per running foot, pounds per pound, pounds per nothing. It's just pounds. That's the load there. What you got here is a similar thing, except you got this being the pressure, 12, 62.4, 5. Okay, so that's, wait a minute. Let me extract that. That's the pressure at that depth. Now, what's the area? The area is at 355. So now I'm putting my 5 back times my 3, and that's the area that that thing is going over. Location, 1.5 foot over. Now he told me this was 1 foot to the left. So this is 1 foot. That looks like a 4. That's 1 foot. This thing from here to here is 2.5 because the whole thing is 5. And unfortunately this one, it goes back that way. And unfortunately, depending on which way you want to look at it, it's a 5/3, a 5/2 this way. I don't, depends on where you're going to take your moment around. We're going to see, oh, I didn't find that load. That load is the area of this triangle. Okay, and we'll go ahead and put the half in there. And I'll say this distance is 12 minus 4. I'm sorry. 12 minus 8, which is 4. So it's 4. 62.4. Now, it's half because it's a triangle. I only get half that load. I got 12. I'm sorry, 4, 62.4, 5, and then 5. So, I guess I'll just do 5 by 5. So that's the value, but it's like half, a third over from this end, the heavy end, 2/3 from the light end. Oh, and then you got this. And that's what you're trying to do. So your question might be, where do I want to take the moments about? Well, first of all, the hinge is going to have some forces. So if you don't take the moment about the hinge, technically hinge X and hinge Y. So if you don't take the moment about the hinge, you're going to have to find the hinge forces somehow. So you might as well, at this point, sum the moments about the hinge. And you get a whole bunch of stuff, but it's not that much. They have nothing but black markers in here. Huh. I guess this stuff. Have y'all ever seen this thing work?
Yeah, you're moving it right now whenever you touch it.
Oh, am I? Oh. But now if I move this back, then can you write on this? Or they would mess it up, wouldn't it?
Well, you gotta use the pen down
Use the
there.
pen that's on.
Oh, okay. Well then, can this show on the screen somehow?
Yeah, you slide it overlays on
Slide
it.
it over so that it projects onto it.
Oh, but I'm talking about the camera. Is there a way I can get? No.
It works this, it would serve the same function as the whiteboard, it's just way so that you don't actually have to use the actual markers.
Oh, and that's it. Huh?
Yeah, it's just a blank canvas for the
Oh,
projector
okay.
to shoot onto.
Oh, okay.
If you didn't, and they were like they were saying, screen share, and if you did screen share on your live stream or whatever, it would show up.
Oh,
You could
really?
write on the whiteboard
Oh, okay.
with that smart board.
I wish they had to put a camera. Every other place they've got a camera. This one doesn't have anything.
I mean, if you had the screen share and the audio, I mean, with the
Yeah. Let's see how this thing looks. Here, let me just look. Everything is just messed up these days. What isn't messed up? Yeah, I'm right there. There I am. It's not the most appealing sight because of the. You do what you can. That's all you can do. So anyway, you sum the moment about the hinges. I was going to go in and circle, and over here you've got this force, and you got this force, and you got that force, and you got that force, and then you got that one. You should be able to get those four. That was just given to you. This one you got to calculate, figure out it's going that way. So you got to go in and you got to do. You got to pick this or that. It doesn't really matter which one you pick. You pick one of them. It's being a positive moment. That's it. So this thing, the pressure on the top forces that to grow a little bit more. Pressure on the bottom relieves it a little bit more. So this is increasing because of that, and decreasing because of that. So now, there's another way to do it, and I think I talk about it in the lecture, but the thing about it is, it's better to, we're already at 12:33. Do y'all, let me ask you this question. If you had an extra lecture like on a Wednesday or something, Wednesday, Friday would be easy. If I did an extra session on Friday using this streaming thing, not in this room, but on the web. So what happens is this thing is being streamed. When it gets all done, after about 10 minutes, it's there. So you can go back and look at the recording. So it's going to be a pretty ugly recording, especially because if you look, there's going to be a big black chunk on the right. Because if you look at this, I could stretch it over, but then I should have done that. But then it clips part of the top. Oh well. Anyway, and so what's funny, watch the stream in a minute, and you'll see I fix it, but I should have fixed it earlier. That's why in different classrooms, so see I'm bringing it up, that's like 5-6 seconds below. Now I fixed it. So.
The webcam's just not angled up enough.
Yeah, it's not, and it's clipped off. And then I did a bad job because on this OBS, you can like do that. And so then you're like, they're looking at, this is what they're gonna see. And it's like, you can't see anything there. But, you know, what OBS will wanna do is fit it, but you can just drag it and make it a little bit better. So, and right now, let's see, how many people are out there? Oh, I'm out there. I don't know, somebody said there's a chat going on. I don't know. So I don't do this, I'm trying to learn how to do this more. So anyway, so would you want one on Friday? I mean, you don't even have to sit in. I mean, it'd just be an extra recording.
Yeah, extra recording would be nice. I mean, if you're
Okay. And this time would be good, about this time? And then if you couldn't catch it, you know, just give it 10 minutes and then it'll be there, you know. Actually, I noticed the other day, I think it's there immediately. That's the thing, they have, does any of your other professors use a Kaltura, or whatever that's? Okay.
I think some of the professors last semester used it, but we, I remember the videos already being there, but I think they were pre-recorded anyway.
Oh, okay. I tried to use it, but it was awful.
Yeah, it was not very good.
And so that's the thing, I think when you do YouTube, which is what's happening right now, I mean, you can go out and search and there are 100 different people that'll tell you how to do something. You can watch a YouTube on how to do YouTube and learn it. But if you go look for some obscure product and say, how do you do this and this, you don't find the help. So I learned from watching YouTube how to do YouTube from watching YouTube. So, should we be gone now? No, it's 12:37. Okay, so now that I've kind of done that, let's see. Well, we can do that one if you want to. This one is the same thing. Okay, so let me just go ahead and do one without a picture. I'll just do one on the board itself. But if I do that, what do I do? I just have to turn off the board, or turn off the projector, right? Let's do that. Okay, so now if I turn off the projector, it didn't turn off.
Button again.
Oh. Okay, so in your midterm, I'll show you the one problem that seems to cause issues. And I haven't put it out there, but this week I'm gonna go ahead and put the whole thing out there. It's one like this, in which what I do is just a concrete. So this is what I call my concrete. And then just a hinge. And then something like that. And then something like that. You're doing the same exact thing, except actually it's easier because you don't have that bottom triangular. And so all you're doing is you're going down here. You're figuring out the pressure prism is what they call it. That's all you're doing. So you got to figure out. I can't. Okay, I should have made the hinge smaller. Sorry about that. We'll make the hinge a real like dot like thing. And we'll say this is 5 feet deep. So on this end, now you can do it per unit depth in the board, and I think that's what I do now. So it's 5 foot deep, 62.4. That's the pressure at that depth. Then, if you're looking at this thing, based upon the geometry, maybe there's an angle right here, you can figure out the depth down here. We can make this different so that it doesn't get in the way. So then you figure out the depth on this end. But what you're doing is you're finding out that depth as well. So let's say this is 4 foot. Then this pressure would be the 5 plus the 4, that's 9, right? So this would be, the pressure here would be 9 times 62.4. And that's pretty much it. So I think, I don't even want to go the direction that some people had worked it before, but I will address it in a video that kind of describes this. But the best thing to do is just break it into a triangle, into a rectangle, with the equivalent load at the correct location, and you're just back in statics. Because if you look at it, this load is that one. This is your little hinge here. Wait a minute. This is this. So you're back in statics. And this would be the hinge, I'll say hinge, I don't know, 1, and of course hinge 2. You know what that's going to be, some of the forces in this direction. Not going to give you anything there, so there's nothing along that way. But there is some stuff this way, trying to break that hinge straight off. You know, it's trying to snap it off that way. That's it. That's all it is. There's nothing more than that. And then you just break it into this. You can erase that and then go back to your loads that are that. That's pretty much it. So it's a fairly straightforward thing. Oh gosh, now it's clipped the top of the screen. Oh gosh. Now, how do I fix that? Here, let's do this. I don't know. This is just nuts. I didn't even mount a camera in the room. Maybe I'll try to change rooms. Do y'all have a particular love of this room?
I've never stepped foot in this class until.
Okay.
When this class ends, I have to go to Rothwell within 10 minutes.
Oh, really?
Okay.
Maybe I'll try to get it in Rothwell.
Or Brown.
Yeah.
Brown's
Can-
really bougie.
Is it?
Yeah, it's like a bougie one.
But you have to get a lot of permission to get in there, right?
I don't
Yeah,
know.
Brown's just used for like orientation stuff. You know,
Oh, okay.
like,
I'll ask. I'll see what I can do.
Brown's nice.
Because it really, So you got a class after this?
I've applied to Rothwell before and after
Yeah,
this.
several
you
of
really?
us, several of us go to Rothwell right after.
Oh, okay, so let's just go for Rothwell. What floor are y'all
They're
First floor.
Third and first.
Yeah, I'm on first floor.
on? Okay, so we'll do an average and try to get the second floor. That'd be perfect for me.
That would be nice.
Okay. I'll send an email to everybody. I know in there the cameras work, you know, and actually they have a thing on the screen I can work on. So I don't know. So for those people who are not here and they're looking at this live stream, we'll try to make it better. So, but I overloaded you with videos. There is tons of videos in this stuff. If you don't like how fast I talk, just speed it up. You know how to do that in YouTube, don't you? Just click that and speed it up. I've noticed that the faster it goes, the smarter the person sounds. So just speed it up twice and then you're in and out real quick. So, well, I'll go ahead and line up to do one on this starting this Friday. And so if y'all are okay with this same exact time, are y'all in Rothwell then? So you could just go sit somewhere, or just pull out your phone and I'll just stream it. I asked